Hello everyone, welcome back to our channel P. Vaishali's Mathematics Classes. I am Vaishali Fulari. Here we are learning a chapter from the 9th standard. The chapter name is Number Systems. In earlier video we have solved question number 1 and 2 from exercise 1.2. In this video we are going to solve the remaining questions. The question number 3 is show how root 5 can be represented on the number line. Till now, we have represented positive numbers, negative numbers on the number line. But this time we are going to represent the irrational numbers on the number line like root 2, root 3 and root 5. Now, to solve this question, we have to take the help of the Pythagoras theorem. A great mathematician Pythagoras, he invented this theorem. This theorem is telling to us that the square of the hypotenuse is equals to the squares of the sum of its other two sides. To explain this, first we need a right angle triangle A, B, C is a right angle. It is right angle at B. First of all, in a right angle, we have to look for the right angle where it is located. Now, as we know, it is at the B. So, opposite of the right angle is always it is a hypotenuse. What is the opposite side of the right angle? AC. So, AC will be a hypotenuse. Now, remaining two sides will be there. One will be the base and other will be a perpendicular. Here we have taken AB as a base and BC will be perpendicular. As I said that hypotenuse square, what is the hypotenuse here? AC. AC square is equals to base square and perpendicular square. What is the base? AB square plus BC square. Shortly we can write this as hypotenuse square is equals to base square plus perpendicular square. So what is the relationship of this root 5 and with this Pythagoras theorem? So I will tell you now. Root 5 can be written as, write this root as it is. This 5 can be written as 4 plus 1. But you may get a doubt that, Miss, can't we write this as 5, 1, 2 plus 3? Yes, we can write. But what the problem will raise, I will tell you. As 4 and 1, these two are the perfect squares of 1 and 2. For this 4, we can write it as 2 square plus 1 can be written as 1 square. So, here we can take 1 as the base and 1 as the perpendicular. We can take any units here. Next, root 5 can also be represented as 2 plus 3. Now, root of this 2 plus 3 means these 2 and 3 are not the perfect squares of the any other numbers. So, how can we represent these numbers? Root 2 whole square plus root 3 whole square. And we know that root 2 and root 3 both are the irrational numbers. For that, we have to represent this root 2 and root 3 on the number line. Then again we have to work for the root 5. Then it will be more complicated. So, we are going to use this 4 plus 1. To solve this question, we have to take the help of the geometry box. Now, let's move towards it. Just now, We discussed that hypotenuse square is equals to base square plus perpendicular square. This 5 can be represented as under root of 4 plus 1. Means here we have to eliminate this square. Means we need h is equals to under root of b square plus p square. Now look here, this root 5 means root 5 can be represented as under root of 2 square plus 1 square. Is it in this form? Yes. So now let's draw this. Draw a number line first. At the middle, we can take as the 0. If we will take 1 unit as 1 centimeter, 1 centimeter, then the diagram will be very small. So here what we will do? We will do that. We take 1 unit is equals to 2 centimeters. Mark to the 2 centimeters. The other side also. 0, 1, 2, 3, minus 1, minus 2, minus 3. This is our number line. 1 unit is equals to 2 centimeters we have taken. Here we have to mention the units also. 0 to 2, dark this line. Here can take as A this point. At that point 2 we can take it as the B. From point B, draw a line which is perpendicular. Here we are taking this 2 as the base and this one as the perpendicular. Means A to B, this will be the 2 units. 2. Now, with this perpendicular, we are going to mark it for the 1 unit. Now, it is our 1 unit. A, B and take this point as the C. Now, join AC. AB is the 2 units, BC is the 1 unit. Now, AC is the root 5, but it is not on the number line. To bring it on the number line, we have to bring this root 5 is on the number line. Here is our root 5. In this way, we can represent the irrational numbers on a number line. Let us solve the question number 4. It is given that classroom activity constructing the square root spiral means the square roots like root 2, root 3, root 4 and so on. We have to construct all these square roots in a spiral way. To constructing the root 2, we need 1 plus 1. We are going to take O P1. Now at P1 take the 90 degrees till the 1 unit. There is 1 unit and 1 unit. This will be our P2. Join OP2. Now this hypotenuse OP2, it is our root 2. Here we have to mark from this point, from the P2, we have to take the 90 degrees. Extend this to 1 unit. It is the 1. Join P1, P2, P3. Now we have to join OP3. OP3 is the root 3. From this point at P3, again we have to take the 90 degrees. Take till 1 unit. Mark this point as P4. Now we have to join OP4. This is the 1 unit. This OP4 is nothing but our root 4. We have to do the same process from this point. The 90 degrees angle with this. Take till 1 unit. Mark this point as P5. Join OP5. This is our root 5. Again from the point P5, take the 90 degrees line or a perpendicular. On this perpendicular, extend the line till 1 unit. All these are the 1 unit. It is also 1. Now mark this point as the P6. Join OP6. It is our root 6. In this way, we can continue the process and we can get the square root in a spiral way. Thank you.